Hey, year 10s. Thanks for coming, guys. Need to do the register as quick as possible. It's nice to see that you guys are now popping up and saying hello. Got Adri, Boyang, Fatima so far. Still got loads of people missing. Let's get rid of that. Sorry. Ethan, Amber, Natanya. Loads of people missing. Oleg's in the house. So is Kate. Doing well. Now we're nearly done now. Keep going, guys. I'm still missing Chimun, Z, Ryan, and Mary. Quick as you can, guys. Let's try and get the reg done as quick as possible. 4 people missing. Guys, I need to apologize. I missed a step in Empirical. So I tried to explain it when I set the homework on the classroom. I tried to give a little bit of instruction. The video isn't working for me. Oh, that's odd. Is it working for everyone else? It's working for me. Still got loads missing. It's working okay for me. Morning, Miss Ryder. Nice to see you. Thanks for coming. Still missing Mary. There's Chimun, finally. A bit late. Missing Zihan, Ryan, and Mary. That's what I'm missing. Still missing a few people. Come on, guys, quick as you can. Year 10, we finish calculations today. You know what that means? It means that you're going to have a test. So just to let you guys know, your test is going to be on Tuesday. Yeah. So on Tuesday, you've got an online Google form test on all the calculation types that we've done. You'll just write your answers. That's it. You'll do all the working on paper, write in your answer, and then it'll mark it automatically. I will, of course, check through the answers as well. But in the meantime, after today's lesson, there's Ryan at last. Ryan, you're late. Right, at this point, I'm going to mark Zihan and Mary as missing, since they are not here. Well, isn't that great news? Yeah, sorry, I took a shower. Right, I'm going to mark them as missing. Oh, there's Mary. Fab, just Zihan missing. Okay, I'll mark Z as missing. And then when he turns up, I'll change his thing to late. It's nice to see you, Mary. I was just saying that we're going to be, you've got a test next Tuesday. Right, folks. Okay, so let's finish off calculations. I'm going to fix the empirical formula bit that I missed. I didn't miss a step in empirical. So let's share screen. Go for that one. There we go. Hide. Okay, let's go through the empirical homework. Now, I've made an error here, which is question 3. The rest of them you should be able to manage. So, question 1, benzene has a molecular formula, C6H6, empirical formula CH. Explain what each of these formulas tells us about benzene. So, guys, this is a really clever question from a GCSE paper. This is pretty much spot on GCSE. Because what they've done here is they've asked a really clever way around of asking for a definition. Yeah? So, question number 1, the molecular formula. The molecular formulae tells us the actual, notice my capitalization, the actual number of atoms of each element in benzene. So we can actually say, brackets if you like, 6 carbons 6 carbon atoms, 6 hydrogen atoms. You can actually say that. Yeah. Number 2, the empirical is the simplest whole number ratio. I'm going to come back to that. Of atoms of each element of each element in a compound. I like it. It was just basically asking for the definition. So I'm going to give you guys 2 marks for this, 1 mark for that one, 1 mark for that one. I'm hoping that you guys used your notes for this. I hope you did. Empirical formula of sodium chloride is NaCl. It does not have a molecular. Explain why sodium chloride does not have a molecular formula. Because it's ionic. It is ionic. Oh, not ionic. Ionic. It's because it's ionic in nature. Yeah. So it's the word molecular. It's getting students to recognize that the word molecular means molecule, which means covalent. Yeah, that's clever, that, because it's ionic. 1 mark. Right. Now, guys, I'm really sorry. This is where I need to apologize. When I was teaching you empirical, I did it with the other class as well. I did it with my triples. I don't know why I keep doing it. It's because it doesn't fit into the lesson. The lesson was getting close in terms of lengthwise, and so I just cut it off. When you run the process, percent to mass, mass to moles, divide by the smallest to find the ratio. Find ratio. Now, here's the problem. If you run all of these steps, yeah, let's just, for fun and games, I can't really make this up. It's a bit of a problem. Yeah. If this final step produces, yeah, we know that if we had X and Y, and we split it and we run the process, yeah, run step 1, run step 2, and at the end divide by the smallest. If we get 1.5 and 2, yeah, the problem is people want to round it. You can't do that. What you have to do is another step, which is to multiply. Yeah, multiply. Because you can't have x 1.5 and y 2, because that is not a whole number. So what you do is, if you get a fraction, you multiply it. And in this case, if you get a half, you times it by 2, which would be x3, y4. I'm very sorry about that, guys. You multiply all the small numbers to get rid of the half. I'm really sorry. It's totally my fault. What that means is, for question 3, I'm gonna discount it. It would usually be 8 marks, but I'm gonna discount it. This one's going to be a times by 2, which means it's gonna be a 5-to-2 ratio. Right, what I'd like you now to do, guys, I'm gonna do one more. Yeah, this one's a third, 0.33. So I'm gonna multiply that one by 3, and I will get, what's 1.33 times by 3? It's gonna be 4, isn't it? 1.33 times 4. So I'm gonna get, sorry, times by 3, 1.33 times 3. Gives me 4, there we go. So that's a 4-to-3 ratio. Yeah, this one is 2/3. So times by 3 again. You're actually multiplying by the denominator. Can I just say, by the way, at GCSE, I've never seen anything other than a half. Never seen a quarter or a third. They don't tend to do it. Yeah. So that one's going to become 3 and what's 2.67 times by 3? 8. Yeah, this one's going to, that's a half again. Yeah, times by 2. So 3 and 2. This one here is 2/3, so times by 3. So that's going to be 4 and 3 again. This one's a half, so times by 2. So that's 2 times 5, 2 to 5. This is a 2/3, so times by 3. So 4 and, no, it's more than that, 5. 1.65 times 3. 5 to 3. And this one's at 3/4. That's a nightmare. They've never done this at GCSE. 1.74 times 4 gives me 7 to 4. That's really hard. Don't worry about that. You're never going to get that much. The only other thing that you're going to get is a half at GCSE. So try not to worry about it too much. I'll set you guys another homework where you'll actually see those. I'll actually set you some real GCSE paper questions just so you can run them. So we're actually going to discount this altogether. There's 3 marks up here, 3 for this section, for the wordy section. We're going to skip this one, but we're going to then run this one. We might exclude some of them as well if we get a fraction. So, okay, steps. Okay, percent to mass. I'm going to do everything in a tiny section. 82.4 grams, 17.6 grams. Right, that's percent. That's my percent to mass. Done. Right, now I need to go mass to moles. This is number of moles equals grams over rams. Right, how much does each element weigh? Because we're counting atoms in empirical. So nitrogen weighs 14, hydrogen weighs 1. So over 14 over 1. 82.4 divided by 14 gives me 5.88. It's actually 8.9 to 3 sig fig. I'm actually going to shrink my pen here, folks. Yeah, and then that's just 17.6. That's nice and easy. Divide by the smallest. Divide by smallest. Okay, so the smallest is 5.89. That one's 5.89. That comes out as 1. And then 17.4 divided by answer gives me 2.95, which is 3. You don't have to multiply that because it's close enough. So it's actually 2.96, which is 3. So this is NH3 is the final answer. Tick it if you got it. Give me a shout out on the classroom, guys, if you got it. Quick shout out would be great. Next, run the same process. Oh, they've done the first step for us. That's nice. Yeah, they've already done it for us. So over 12. They've already done the percent to mass for us. Tick was already done. Yup, thanks Oleg, good to hear. Now I need to do mass to moles. Yeah, we count, remember, moles counts particles, over 12 over 1. So 1.24 divided by 12 gives me 0.103. And then that one, of course, is just going to be 0.26. Divide them all by the smallest. Divide by smallest. The smallest is 0.103. 0.103. Uh-oh. That's going to come out as 1. And then 0.26 divided by 0.103 gives me, there's a fraction. Right, so if you got that number, I will give you the mark at that stage. Yeah, if you got that, you can have it. You should have it in your working out. Great job to hear that. Yup, that's great. Now, guys, it's a fraction, it's a half, which means I'm going to multiply this whole thing by 2. So the final answer for this should have been C2H5. That's the real answer, but I will give it to you guys if you've got that in your working out. Yeah, because I'll give it you for either answer. If you've done the multiply, then fab, then you've read ahead. That's great. Yeah, but I apologize for not having taught you the multiply trick. I'll set you another empirical homework to reinforce this, guys, so don't worry. Next, right, percent to mass. Oh, I clicked on the black. That's really irritating. Right, percent to mass, 52.9 grams, 47.1 grams. Right, mass to moles, grams over rams. Aluminium weighs 27 on the table, oxygen weighs 16. 52.9 divided by 27 gives me 1.96 to 3 sig fig. 47.1 divided by 16 gives me 2.94. Uh-oh. Divided by the smallest. Yeah, divide by smallest. So, this is going to give me another fraction, isn't it? 2.94 divided by 1.96. Oh, exactly 1.5. If you got that number, you can have the mark. But again, multiply by 2. Final answer, AL203. Multiplied by 2. Apologies. If you've got that other number, you can have it. Right, they're getting harder. Right, percent to mass. They've already done it. Why, thank you. I'll take that. Next, mass to moles. Grams over rams. Over 23 for sodium. Over 1. Over 12. over 16. Right, 0.219 divided by 23 gives me 9.52 times 10 to the minus 3. This is 0. By the way, I don't like those numbers. So I think I might have taught you this already. You can get rid of this. Once you've got this on your calculator, yeah, you can get rid of the standard form. If you press Shift-Eng, it'll drop it out. So I have pressed Shift and the ENG button. Yeah, Shift and then find the button for ENG. Yeah, Eng. And that now changes it to 0.00952. It's nice. This, of course, is 0. I'm just going to get rid of that now. 0. Because that's just divided by 195. Right, 0.114 divided by 12. Shift-Eng, 0.0095. Isn't that interesting? Do you notice the numbers are exactly the same? 0.457 divided by 16. Oh, it's different. 0.0285. That's interesting. Much bigger. 6. Divide them all by the smallest, which is 0.0095. Divide by smallest. So 0.095, 1, 1, 1. Divide that number by 0.0095. 3. Final answer. NHCO3, sodium hydrogen carbonate. There's your final answer, folks. Tick it if you got it. Tick it if you got it. No fraction, no multiply. Next, right, percent to mass, step 1. 3.1 grams, 31.6 grams, 65.3 grams. Right, mass to moles over 1. Phosphorus is 31, I believe. Oxygen is 16. Can someone check the table and check me I'm 31? I think I am. So that's 3.1. 31.6 divided by 31 gives me 1.02. Next, 65.3 divided by 16 gives me 4.08. Right, divide by smallest. Yeah, 1.02, 1.02, 1.02. So 3, 1, 4. Final answer. H3PO4. Tick it if you got it. Tick it if you got it. Next. Right. Percent to mass. Already done it for us. I love it when they do that. Makes me so happy. Grams, mass to moles, over 23, over 12, over 16. You get used to these numbers after a while. 0.167 divided by 23. Shift-Eng, 0.00726. Next, 0.0435 divided by 12. Shift-Eng, 0.00363. 0.174 divided by 16. Oh, no eng needed. 0.0109. Divide them all by the smallest. Right, divided by 0.00363. Divided by 0.00363. Divided by 0.00363. 1. It's nice. 0.00726 divided by 0.00363. 2. Look at that, exactly. 0.0109 divided by 0.00363. And I get 3. Final answer. Na2CO3, sodium carbonate. Tick it. Right. Oh, this is a bit harder now, folks. This now gets harder. 0.1150 grams of copper reacts with oxygen. Form 0.188 copper oxide. Find the empirical formula. Right. That's clever. So this, the copper is reacting with oxygen to form copper oxide. Right, balance the equation just for fun. Just for fun and games. Right, I had 0.15 grams of copper. The question I want is, I want to do the empirical formula for copper oxide. So there's my things. Yeah, and I now need percentage. Yeah, or grams. Percent to gram mass, mass to moles. Well, I've got mass of copper. That I can put in here, 0.15 grams. How much oxygen did I have? Well, it told us that I made 0.188 grams of copper oxide. Guys, conservation of mass. Mass must add up. The mass that went in must add up. So if I do 0.188 minus 0.15, 0.188 minus 0.15, I reacted 0.188 minus 0.15, yep, and I got an oxygen of 0.038 grams. So there's my grams of oxygen. So you had to do a second step. Had to do an extra. There's a point there, grams. Okay, now we've got our numbers. Mass to moles. Copper is 63.5 on the periodic table. Oxygen is 16. 0.15 divided by 63.5 gives me shift eng on my calculator. 0.0. Don't ask me why I have to do it twice. I have no idea. Yeah, 0.038 divided by 16. Shift eng. No idea why I have to do it twice. 0.00237. Huh, it's the same number. Divide them by the smallest. Isn't that lovely? 1. It's the same number. So the final answer is CuO. Tick it if you got it. Right, guys, that was much harder. Give me a nod on the classroom, please, if you got it correct. Much harder question. Really, that was much more difficult. Having to make a realization of conservation of mass. Give me a quick shout out if you got question 5 right. That's a big leap, that, guys. Well done, Oleg. Great job. Fatima, well done. Adri, well done. If you guys are doing that, you're doing great. That's a massive leap of faith. Well done. Can people tell me if they got it wrong? That might be a better question. Z, well done. Okay, last one. So phosphorus. Now, it's always nice to do little bits for A level, in case anyone decides. Well done, Amber. So it's always nice to do little bits of A level. And phosphorus is a terrifying element, actually. I don't have it in my collection. And phosphorus is rather unusual because phosphorus actually travels in 4s. So P4 is phosphorus. And it's reacting with fluorine. Any ene ends in a 2, of course. It's anything ending in ene is in a pair. Going to form phosphorus fluoride. Yeah, it's probably that. We'll find out now. So it says 1 gram of phosphorus reacts with fluorine to form 2.84 grams of phosphorus fluoride. We don't know the number there, by the way. That there is a question mark. Yeah, X and Y, that's what we're looking for. Yeah, there's the question mark. So the first thing is we can do is let's do phosphorus atoms and fluorine atoms. Well, we know how much phosphorus we had. We had 1 gram of it. The 4 doesn't matter, by the way. It's just nice to know that it travels in 4s. Remember, in empirical formula, you're counting atoms. And they've already given us grams, which is lovely. Yeah, the question is, how many grams of fluorine did I have? Well, conservation of mass. 2.84 minus 1 gram minus 1 equals 1.84. That's nice. Nice and easy. I don't even need a calculator for that one. 1.84 grams. Right. Now we can get to empirical. What does phosphorus weigh? 31. Fluorine weighs 19, I believe. So 1 over 31. I know I'm a nerd knowing them. 0.0323. Next, 1.84 divided by 19 gives us 0.0968. Right, divide them all by the smallest. 0.0968 divided by 0.0323, and I get 299. The answer is 3. So final answer, PF3. And we're done. End of worksheet. Right, let's add up the marks. Add up the marks. So we've got 3, 4, 5, 6, 7, 8, 9, 10, 11. It's out of 11. Whoop, whoop. Total out of 11. I really want to put a smiley face on there. It's weird. I'll get rid of that. So it's out of 11, folks. Let's add them to our data sheet. Add them to our sheet, folks. So it's out of 11. I'm sorry about not doing the multiplying bit. I just missed it. Do you know what? If I wasn't doing this online teaching thing, I wouldn't have missed it. But oh well, doesn't matter. Done now, Google. And I've got plenty of time to finish my lesson, guys. We're going to finish calculations today, which is great. So starred out of 11. So you can fill in your data. Mary, I'm missing marks for your last 2 homeworks. If you could fill them in for me, that would be great. If you want to go through the webinar again, they're always there on the YouTube channel. Yeah, they're all labeled with dual award. I need to list them, actually. It would be a really good idea. What I should have done is, I should have linked in my lessons to the, oh, it doesn't matter. Out of 11, which is amazing. Laptop is still struggling. Out of 11. Well done, Kate. Well done, that's great. And this is Empirical. Good job. Guys, you've done amazing. Really proud of you. Done great. Really, really pleased. Oh, thank you, Mary, for filling in your data. You're a star. And 7's a really good number. I'm really impressed. Look at this, Mary. You are doing so well. Well done. Ryan, doing great. Guys, I'm so proud of you. I'm so proud of what you guys have achieved. These are such great results. You guys have done so well. I promise you this will translate to a good test result. Yeah, you can always go back and rewatch them. I should link in the videos. I need to do that. The problem is there's so many YouTube videos now that I'm getting lost in my own YouTube video channel. It's a nightmare. Right. Okay, guys. You guys have done great. Well done. Right. Today's lesson, last lesson of calculations. Title for today's lesson, percentage yield. Percentage yield. Right. Percentage yield. Number 1, learning objectives. Number 1, understand practical chemistry. Number 2, be able to calculate, know the equation. Know equation, which is really easy. Know equation for percentage yield and be able to calculate. Right. So, a couple of notes, not many. Very little writing today, folks. Yeah, I'm going to keep it simple. Okay. So, in chemistry, oh, come on, Mr. Duncan. In chemistry, we can predict output, or we can predict outcome using calculations. Let me show you this in action. Yeah, don't want to take my learning objectives away. So hydrogen reacts with oxygen to give you water. Balanced equation. 100 grams of hydrogen goes in. How much water comes out? Step number 1, get 2 moles. Find moles. Number of moles is grams over rams. So we've been given 100 grams of water. Yeah, and sorry, 100 grams of hydrogen, and hydrogen weighs 2 because it's in a pair. Yeah, it weighs 2. That's because hydrogen is 1, but it's in a pair. Right, so we can predict that. So that's going to give me 50 moles. Right, step number 2, mole ratio. Yeah, we know this well now, folks. And it's a 2 to 2. I'm going to make 50 moles of water because it's the same number. Right. The problem is chemists don't work in moles. Sorry, chemists, you can't buy moles. You need to work in grams. So step 3, get out of moles. Yeah. Rearrange the equation. Number of moles times rams gives me grams. What does water weigh? 18. I've already used the 2 in the ratio. So 50 times by 18. 900. I'm going to make, in that reaction, 900 grams of water. How much oxygen am I going to need? Well, you can actually predict it, can't we? 800 grams. Let's check. That's just a prediction. Yeah, mole ratio, 2 to 1. How do I get from there to there? Divide by 2. 25 moles of oxygen. How much does oxygen weigh? Oxygen on the periodic table is 16, but it's in a pair. It weighs 32. Times by 32. What's 32 times 25? And I bet it's 800. Look at that. Isn't that lovely? Yeah, 800 grams. Adds up. Isn't that amazing? It's just magic. So we can predict what we're going to get. Yeah? So the predicted outcome, yeah, we can predict outcome, yeah, using calculations. But here's the thing. We never get that. In chemistry, we can predict outcome using calculations. However, we never get 100%. We never get 100% of what we calculate. Now, you guys are going to understand this because it's like chemistry is cooking, yeah? And everybody here will realize that if you're cooking, you always lose a small amount of something left, right, and center. Yeah, you always, if you're trying to make 10 cakes, you're going to burn a cake. Yeah, if you're using the flour, you're going to spill some of the flour. If you're adding water, some of the water will get spilt. You never get what you expect. Yeah, but we can get close. And this is what percentage yield is. Percentage yield I've suddenly realized I want to make this easier. Percentage yield equals actual practical output, actual out over calculated out. Yeah, so we predicted that we calculated we're going to get 900 grams. So here's an exam question. Stephen calculates that he will make 900 grams of water in his experiment. He actually makes 725 grams of water. What is his percentage yield? Actual percentage yield is actual over calculated times 100. I missed the 100, my apologies. Yeah, there has to be 100 at the end because otherwise you're going to get a decimal. So what did he get? So Steve actually got, he got 725 grams. He thought he was going to get, he calculated 100, and his percentage, 725 over 900 times 100, gives me 80. I said something that makes me different. 80.5%. That's it. Guys, that is it. And that is the end of double award GCSE calculations in chemistry. That is it. Let me give you another question. That literally brings us to the end. It's super easy. Yeah. Let's give you another question. I don't want to rush you guys. Question number 2. Okay. Amber makes 60 grams of, I don't know, carbon dioxide, but was expecting, I'm giving you all the different types of ways that GCSE have done it. Amber makes 60 grams of CO2, but it was expecting 77 grams. Percentage yield? Question mark. Yeah, nice and easy. Have a go at that for me, folks. Pause the video now and have a go. Show you're working out. Yeah, it's always good to show you're working out. Percentage yield equals actual over calculated times 100. Input my data, therefore. Actually, she got 60. She was expecting 77 times 100. What you realize, guys, is if you ever get over 100%, you're wrong. I get 78%. We're done. This is not complicated. You ready for question number 3? Gonna make it harder. Gonna make this a proper go. Okay, guys, question number 3. I'm taking you all the way up to grade A now, folks, at GCSE, because I'm going to combine a reacting mass and a percentage yield. Yeah? I'm gonna give you an equation. Balance it. Okay. I'm going to give you 200 grams of nitrogen. What mass, stage number 1, what mass of ammonia am I hoping to make? Go. Right, guys, run the reacting mass calc for me, please. Off you go. Pause the video now. And then once completed, unpause the video. Okay, before I do that, I'm going to say that Mr. Duncan actually makes 180 grams of ammonia. I should actually give you a realistic number. Give you a realistic number. 90. Let's give it 90 grams. So, percentage yield. What is his percentage? I'll actually write it in words. His percentage yield. Okay, so this is now grade A, year 10s. And I know that you guys are doing double award, but you're still aiming for that level 9 if you can. I know that, and you guys can do this. Yeah? So the first thing we've got to do is we've got to run the calculation first. Yeah? We need to calculate, because we know that percentage yield is actual output over calculated times 100. Well, we have the actual. We're going to make 90. But the question is, what was the calculated? So we need to run a reacting mass calc. So step 1, get to moles. Grams over rams. What does nitrogen weigh? Nitrogen weighs 14 on the periodic table, but it's in a pair, 28. So 200 divided by 28 gives me 7.14 moles. Step 2, what is my ratio? My ratio, this is where I'm very sorry, I've run out, I've gone and squished myself, haven't I? Yeah, there we go. I'll put that there. Mol, M-O-L, it's the units if you wish. The ratio is 1 to 2. So I need to times by 2. Times that number on my calculator by 2. I haven't used the one I've done there. That becomes 14.3 on my calculator now. Right, there, use the ratio, step 2 done. Ratio, tick. Step number 3, get out of moles. Yeah, rearrange the equation. Number of moles is grams over rams. Let's reorganize it, bring rams over. Number of moles times by rams gives me grams. How much does ammonia weigh? Nitrogen is 14 plus hydrogen, which is 1 times 3. Total weight is 17. So I'm going to multiply 14.3 times by 17. Times that number on my calculator by 17. And that takes me, I was expecting 2 times by 17, and I get 243 grams. That's what I was expecting. Yeah, so now I can run my percentage yield. So what yield did I get? 90 over 243 times 100. 90 divided by answer times 100, and I got 37%. And I'm done. We're finished. So guys, if you can do that, you can do anything they throw at you. That actually brings us to the end of calculations for for Dual Award GCSE. Right, year 10s. What I'm going to do is I will post on the classroom. I'll post another empirical for you to have a go at. Won't be many. 5 questions, done. Yeah, I'll just make sure that they all have a fraction. So you have to do a multiply at the end. No, that's not true. I'll give you a mixture. Yeah. I will also post you a percentage yield worksheet as well, because we're done now, folks. That's it. So next lesson on Tuesday. So you're going to have the whole, so you got tomorrow, Saturday, Sunday, and Monday. And there's no lessons on Monday since we're not in. So you've got the whole of Monday to revise. Can I also tell you, I'm going to be here on that Monday. If you have any questions, send me a Google Hangout message, and I will call you personally to support you if you need any help going through any of the topics. Just a quick reminder that there is something really handy on the lesson 1. In your notes, in your book, you should have these. Here is all the calculation types that you are going to have in your exam. You're going to have formulae, AR, MR, percentage composition, moles, reacting mass, by the way, is missing, should be there, empirical formulae, water crystallization, and percentage yield, and that's it. That is all. So if you go through your notes, everything is there. The YouTube videos are there as well. If you want if you want some practice questions, you're more than welcome. Just send me a message and I will put some together for you and I'll send them over. Happy to do so. Guys, I hope you have a nice rest of your day. I'll put all those sheets on the classroom by the end of the day, and I'll see you all soon. Take care, guys. Thanks.